Hey there, this is Tony here, and today I'm going to show you a fairly short video, 5 or 15 minutes, of processing a image that was captured using a Seestar S50, and the image is the NGC6888, the Crescent Nebula, and I captured that using N.I.N.A software, which I like to use because it gives me a lot of screen real estate instead of using the tiny phone app that comes with the Seestar. And then I processed in Siril, leveraged StarNet for star removal, and then finished up with Photoshop. So let's get started. I've got the image already opened up in Siril. And so this is the image that has been aligned and stacked using Siril. And so there was a series of FITS files that Seestar created. And so I've gone ahead and aligned and stacked those. It totals quite a bit of time. It's about 6 hours and 16 minutes worth of capture. And so let's go ahead and start the process. So you'll notice that the image is very, very dark. And that's because I'm in linear view here in Siril. And I'm going to switch over to what's called auto stretch view. And so this is just a viewing mode. I haven't edited the image file at all, but you notice that there's definitely some glow on the edges of this image because of maybe street lights on the surrounding areas where I was capturing, and then also some stacking artifacts where you can see some lines here. So we're going to get rid of those, and then we'll proceed with the process. I think what I'll do first is I'm going to rotate the image counterclockwise. So there's a little box here in Siril, so I'm going to click on that, and just gives it a more sort of natural look to me than having it in portrait mode. And so the thing you'll also notice is that on the edge of the image is quite a bit of noise shown up by this sort of grain on the edge. And so what I'm going to do is I'm going to hold down my left mouse button in Windows, and I'm going to drag a rectangle. Let's drag it to about here. And so then we can kind of not be processing these artifacts on the edge and this glow. Maybe drag it a little bit, maybe to be a little bit bigger. There we go. We'll stop there. And then we'll right click and click on crop. So now we've cropped the image. The next thing in Siril we want to do is you'll notice that there's somewhat of a background gradient on this. There's sort of these light areas here, and then maybe some light areas here, but coupled with that is actually some background nebula. So we have to be careful on how we do this background extraction to remove this glow. So there's a tool here under scripts. And if I go to Python scripts and processing, and then GraXpert. So GraXpert is an AI tool, which I'm going to run that script. It brings up a dialog box. I'm just going to accept all the defaults. So the operation is background extraction. The AI model is this version here, 1.0.1. And again, leave the smoothing just at default and then click on apply. Just takes a few seconds for it to complete. And if I close that, you'll see that glow on the edge there has definitely been improved, removed. The next thing I want to do is go over to Tools and Astrometry and click on Image Plate Solver in Siril. And this will also bring up a dialog box. Now, what I want to do here is this Image Plate Solver is just a way of telling Siril some capture information about the object. And so it's got some basic information here from the camera, from the file, such as the focal length and the pixel size. I'm just going to click on OK here. And you see there that this dialog here on the right-hand side, it now gives Siril a bit more information about the image. And this helps on the next step, which is image processing and color calibration. And I'm going to select Spectrophotometric Color Calibration. It too brings up a dialog box. And I can select the sensor type. So Seestar is a one-shot color camera. You can actually check and select this sensor model. There it is, Seestar S50. And I did use the light pollution filter. So I'm going to select that as well and click on OK. And when it does that, you see the colors very, very subtly change. They've been calibrated to a known database. And that's really all this step is doing. All right. So what's next? So some people, just for aesthetic purposes, like to reduce how many stars show up in an image. And the reason we do that is then you can kind of emphasize the object itself without the clutter of this massive star field. And to do that, there's a couple of tools in Siril that you can use. And I'll show you those tools. So the first one, if I go to scripts and then Python scripts down here, there is under this tool here, Psych1, it's called Starless. And so that is a free Python script you can use. There is also another one, which is a paid tool. So if I go to RCAstro, this is another script that I've installed into Siril. And you can see there's a tool there called Star Exterminator, which is a paid tool. So that's a paid option. And some people, would argue it maybe does a slightly better job or a different job to the Psych1 Starless, but I'll leave that up to you to try it out if you wish. The other tool that I've used for quite a bit is called StarNet. So if I go down to Python scripts and then StarNetAstro, I've also installed this script, StarNet. And so I'm going to run the script. This is also a free tool, and it brings up a dialog box. And what I'm going to select here under the options is I'm going to select linear data. And the reason I do that is I haven't stretched this image at all. Stretching is basically increasing the brightness and the contrast and playing around with other parameters. So the image is fairly untouched other than that crop and that color calibration that I did. The next thing that I want is I want to decide, well, what output do I want StarNet to give me? Well, I want it to give me two outputs. One is a starless image, and then the other one is a star layer, which is just the stars only. So I'm just going to select that and click on Run StarNet. So I run it, and it does its magic in the background pretty quick. And we'll go ahead and close that dialog. So now you see we've got this nice image without the stars. And I've also got a stars only image, which I'll show in a few moments. So now we can go ahead and do some more processing. The first thing you'll notice is I'm still in auto stretch view. So I want to call that out because a lot of people do these StarNet or star removal steps, and then they see this weird mottling in the background. So rest assured, we will address that in a few moments. I'm still in auto stretch viewing mode. The first thing I want to do is I want to go ahead and slightly sharpen the nebula. So I'm using my mouse wheel in Windows, mouse wheel up to zoom in, scripts, Python scripts, processing. And there's a script here I've installed called Cosmic Clarity Native. I'm going to click on that, and it will bring up a dialog box. And I'm going to select here, I want to do sharpening, but I only want to do it on the nebula, so non-stellar only. And I'll leave all these defaults for the non-stellar, about 0.5. And then I'm going to click on Run. And you see when it does that, just takes a few seconds on my computer. And you see there's a very subtle sharpening effect has taken place. So if I do a before, which is this arrow here, before, and then after. So a nice amount of sharpening without too much sharpening. But also you'll notice that there's a bit of background noise showing up here. So let's go ahead and reduce some of that background noise in the image. So I'm going to go to scripts, Python scripts, processing, and actually I'm going to go back to GraXpert. And I'll show you what that does in a few seconds. So it brings up the dialog box for GraXpert. And for the operation, I can now select denoising as the operation. And it has here a different AI model, which gives you the version number here. I'm going to leave the defaults at 0.5 for the denoising. I've got a powerful computer with a powerful graphics processing unit, so I can leave all that on and checked. And the reason I do that is it'll be a much faster process. So click on Apply. And then you'll see there behind the scenes, in Siril. Some dialogues appearing. The processing moves along at a pretty rapid clip, and it's complete. I can now close this dialogue. So if I do a before and then a after denoise. Now, again, remember, I'm still in auto stretch viewing mode. So now I'm going to get out of that. I'm going to go into linear view. And when I do that, you can see that the image drastically darkens. Sometimes I've seen, from my experience, you start to see the nebula appear, but to get rid of that for this first stage, a little trick here is the image processing stretch. Just click on one of these, this one, and you see that it kind of disappears. And so I'm not sure exactly why that happens, but just in case it bothers you, you can get back to a black screen, which is what we would like for the next stage. We're going to go to scripts, Python scripts, and then we're going to go down here to Verilux. So these are some other scripts that I've installed into Siril. First one is called Hypermetric Stretch. Run the script. Brings up a dialog box. And you can see I can select the sensor profile here. I can do a live preview, which I would like. And so I can see the impact of what this stretch will do to the image. And it looks pretty good to me, actually. You've got some nice nebula in the background. The grain is kind of reduced from that denoising that we've done. If I use my mouse wheel to zoom in and then drag up, this area here, I've noticed sometimes can get a little bit burned out, but the hypermetric stretch is has handled that quite well. One thing I will say, though, is the target BG that I've selected is 0.15. I believe the default for hypermetric stretch is 0.2. And if I show you, if I go and click on defaults, you can see that what that does. It actually brightens up the image, and this part here starts to get burned out a little bit. So let's go ahead, select the sensor profile, which is the Seestar S50. Let's take this BG down to about 15. Click on Auto Calc here. And so we're back to where we were. That nice image, nice colors, not burned out here. And I can click on Process. Close this. And so we've now made some headway on the image. One thing I will call out, my seeing conditions for this capture were pretty average. There was some haziness in the sky when these were captured over the 6 hours or so capture. So certainly with your Seestar, you've got better seeing conditions. I bet you could get a better image than this one, but it's not too bad. We've got some outer nebula showing here, which is quite nice. The next thing you want to do is go to scripts, Python scripts, Verilux, and I'm going to select a script called Revealer or Revealer. Click on that, run that script. And this basically emphasizes some of the contrast or micro contrast in the nebula. So I'm going to mouse wheel up, zoom in. Now, if I drag this texture all the way to the right, you can see that looks pretty unnatural to me. So if I go back here, let's go to about a quarter of the way. That's not too bad. It looks a bit more natural to me. The structure, I'm going to just grab that just right about there. And then if I hit the space bar, you see the original, release space bar, and there's the effect. So click on Process. And now we're done. So we're done with, let's see here, crop, color calibration, plate solving, stretching, sharpening, and revealing some more of the contrast as well. So then I would save this image, and let's call it starless dash, and I'm going to save it as a bits file. And let's see here. It brings up a dialog box here for saving the FITS file. I'm going to save it as a 32-bit and click on save. And we're done. So what's the next stage? It would be nice now to bring the stars back into the image. And there are a couple of tools you can do that in Siril. One is under image processing, there's star processing, and this star recomposition here. If I select on that, it'll bring up a dialog box. And you can see here what I can do is I can select the background image, which is what we just had, the starless, and then I can bring in the star mask. So this is one way you can do it in Siril. The other way, which I'll show you, so let's close this, there is another script in Siril, Python scripts, and if I go to Verilux, it's called Star Composer. So let's go ahead and show you this one, knowing that there are other options to do this. So I load the star mask, which is, remember, that was the D screen. So double click on it, and then I'm going to load that stretched starless image. Double click on that. And so now we want to kind of bring the stars back into play. And to do that, there is a area here where I can drag this all the way over. Let's go crazy. Let's go all the way to the right. You see that? Look at that. Way overloaded with stars. It's too much. But if I back off and go down to here, and a lot of this is just personal choice. I mean, you can go right down here and there's nothing. You go up to here, maybe a third of the way. There's a few stars. That doesn't look natural to me. And then you go up to here, maybe 13 or 14 on the scale. And again, a lot of this is just personal choice. So what I'm trying to do is I'm trying to emphasize the nebula and its surrounding regions without kind of being overloaded by the stars being present. And so now I can click on Process. And there we have it. The other things you can do is after this processing step here, you could go into Photoshop, which I'll show you right now, just a few little tricks in Photoshop. And let's minimize this. I've already opened that image in Photoshop. And I'd saved it as a TIFF file, to be clear. So I'd saved it as a TIFF file in Siril as 16-bit TIFF, just to be clear. And that's because Photoshop requires a 16-bit TIFF. And one of the things you can do in Photoshop is if I use my mouse wheel to zoom in a bit, you can maybe emphasize some of the saturation levels a little bit. So you can go into Filter, then you can go into Camera Raw Filter. It brings up a dialog. We don't want that. It brings up a dialog, and then I can go down to here. I can go saturation. I go crazy on the saturation, which looks completely unnatural. Or let's just back it off. Let's take it to about maybe 20 right there. I can edit the vibrance, which kind of emphasizes some of the contrast. Don't go crazy on that one. And then clarity is the other one that I look at, which kind of emphasizes some of the areas as well. So if I go all the way to the right on contrast, you can see it really kind of brings out fine detail, but it, again, doesn't look natural to me. So I'm just going to take it down to about 10. Click OK. And there you would have it. That would be your finished image of the Crescent Nebula captured in Seestar using N.I.N.A software, processed in Siril, leveraging StarNet, and then finished up with Photoshop. And by any means, you don't have to use Photoshop. I just use it because I happen to have a subscription to Adobe Creative Cloud, but you can use GIMP, which is free. You can use Affinity, which is also free, to accomplish some of these steps. All right, so thank you for your time. Subscribe to this channel if you like it. I've got plenty more videos looking at different objects and how to process them. Thank you very much for your time.